So I'm going to share my screen. I am, just for the purpose of recording this, I have a Zoom going. So let me share my screen and then we'll get started. I have water. There we go. All right. So, Jaime is going to be hopefully able to join us for the pool sessions. Walt, we have 3 of you who are Divemaster candidates, but only 2 of you are going to be moving forward. Walt is going to just observe and continue to get more practice with the hands-on stuff and observe the rest of the stuff. And whenever he's ready, he'll do everything else. So, but I encourage you, Walt, to come to as much as possible because it does start to, you know, really it gets easier the more you come. So let's go ahead and move forward with the next lecture for Divemaster Institute. And we'll talk a little bit about using Dalton's law for nitrox. And Ronny, feel free to jump on in here at any time. You can tell I'm starting to lose. I have yet another sinus infection, so I'm starting to lose my voice again after a 10-hour teaching day yesterday. So, so the partial pressure of oxygen at 132 feet of salt water for a mixture of 32% oxygen will be, what do you think? How many atmospheres absolute is 132 feet?
That's 5.
Yeah, good. So it's 5, and then we're going to take 5 times what?
Point.
The percentage of. No, it's simple. It's the percentage of oxygen.
Oh,
It says 0.32.
0.32. Okay.
Yeah. Okay. So, and that gives us 1.6. So it gives us 1.6 atmospheres absolute for partial pressure. Now, for a mixture of 36% at 114 feet of salt water, what would we do?
So we first have to figure out the ATA.
And how do we figure out the ATA? What do we divide 114 by?
62.4.
No.
Oh, shoot! I was doing.
That's okay. Listen, it's quite all right.
Too many numbers.
It's just a salt water versus fresh water.
14.7.
No, that's PSI. So think about
The other, the 0.4 that I'm missing, or no?
no, it's atmospheres in feet. How many feet of seawater is in 1 atmosphere? How many feet of seawater is in 1 atmosphere?
33?
Yeah,
Okay.
yeah, 33.
We gotta figure out how many atmospheres.
Exactly. So just yeah,
Oh,
right. And then and the plus 1 is that at the atmosphere at the surface.
Mhm.
So we take 114 divided by 33 plus 1, and we get 4.45. Now listen, if it was fresh water, what would we divide it by?
34.
Yeah, exactly. Okay, and so we get 1.6. All right, Charles' law. For any gas at a constant pressure, the volume of that gas will vary directly with the absolute temperature. I go over this one a lot, and it's actually called different things, but how much PSI for every degree Fahrenheit? For every degree Fahrenheit, and for every degree Fahrenheit, how many PSI does it change? I've actually said it a bunch of times because this is one of my favorite laws. Yeah, just take a wild guess. You know it, Bill. Yeah, Bill gave it away. Okay, Bill's like.
I watched the video the other day.
It's okay. So yeah, and the more you hear it, you'll be like, I know this, so it's fine. Yeah, so 5 PSI. So, all right, let's talk about heat transmission. A cylinder filled to 3000 PSI at 130 degrees Fahrenheit will reach what pressure when cooled to 70? How would we do that? We'd subtract. What would we subtract?
71.
Yeah, so here we go. 130 minus 70 equals 60 times 5 equals 300 PSI change. So 3,000 minus 300 equals 2,700 PSI. Heat transmission of gas is directly proportional to its density. And air breathed by a diver transmits heat at a greater rate at a higher pressure and density. So a diver loses heat in water, and this is in your open water lecture, how many times faster than in air?
25,
How much?
25.
Good job, 25, excellent. Okay. And listen, I don't expect everyone to remember all this stuff. This is just to help refresh your memory on the things. All right, Henry's law says the amount of gas that will dissolve in a liquid is almost directly proportional to the partial pressure of the gas. So understanding Henry's law helps us understand what effect.
The decompression.
Yes.
constant.
Decompression sickness.
Mhm.
Okay. Solubility and temperature. The lower the temperature, the higher the solubility. As temperature rises, the gas comes out of the liquid more easily. How does this affect decompression sickness? What about cold dive?
You wouldn't want to. Is it that you're talking about like before it happened, like while it's happening or after the fact?
Before.
Oh, okay. Well, based upon what this says, as temperature rises, the gas comes out more quickly. That means it would be faster in warmer temperature. So in cold water, it would more
Cold.
slowly fit into your system than.
So cold air, cold water, lower body temperature, warm shower after the dive or hot tub is, that's right, it's a big no-no. I see you shaking your head no, because the diver tends to fizz inside. All right, kinetic theory of gases. Molecules of a gas are constantly in motion. If heated, motion increases, which increases pressure. If volume is reduced, motion increases, increasing pressure. When gas is added, more molecules equal more motion, increasing pressure. So, the study of underwater physics helps us understand physiology, equipment function, how to work underwater, and diving safely. And don't forget to review diving fundamentals for leadership, and then look at the physics chapter review questions. So I think Jacob could probably teach the next one. It's equipment mechanics. But anyway, you know, the lecture that I just did, that's really to refresh your memory on some of the physics stuff for a dive master. All right, equipment mechanics. So we're going to talk about cylinders, valves, regulators, buoyancy systems, information systems, and problem detection and solutions. So steel cylinder markings, ICC to DOT, 1970. What does that mean, Jacob?
So ICC was originally what they were before they became DOT. I forgot what it stands for, but.
You don't need to know. It's okay. Yeah. That's good. That's good, Jacob. Thank you. So a plus mark can add 10%.
And that's only on steels, typically 2250 in pressure.
Say that one more time.
Usually on the low pressure steels, the 72 cubic foots, which are 2250, and they usually have a plus on them.
Very good.
If you can do this, you're
All right. 3A and 3AA.
this ain't an L, but so the 3A is typically aluminum, 3AA is a steel composition.
Steel cylinder pressure ranges. All right, aluminum cylinders. First in the United States in 1971, and they were 2475 by 69. 6.9 diameter. Okay.
So the average aluminum 80 is around 7.26 inches in diameter.
Okay. So they were thinner then. I know I've had some donated to me, and they are, you know, definitely thinner back then.
Also different aluminum used.
Yeah. So in 1972, were the first 3,000 PSI, 6.9 diameter. Markings for aluminum, SP, 1972, E, 1977, 3AL, 1982, no plus markings on aluminum.
So the SP is known as a special permit. E is exemption, and 3AL is just for the aluminum.
Good job, Jacob. Thank you. Cracking problems pre-June 1988. Have you seen that in the shop?
I've found cracks many times.
Yeah. Steel versus aluminum, advantages and disadvantages.
So with aluminum, they are more prone to cracking and corrode, but in comparison to a steel is like the flash rust. So if the inside gets wet and it dries, they will literally rust in a matter of seconds. But the steels will last longer. They're more prone to failing hydro tests. The actual visual test is where the aluminums typically fail, and that's where there's cracks found, insufficient number of threads, and we condemn the cylinder, corrosion, pitting, things like that. And steels have thinner walls as well.
Great. Here's an example of what it looks like to see a steel cylinder with rust. I'm sure you have. You could probably give us some better pictures. Cylinder manufacturers include Luxfer, Catalina, Press Steel, Faber, which is what I have, Kitty and Waddington.
I'm pretty sure Kitty they're typically the ones with almost a bell shape to the neck. There is a few missing.
Yeah,
but
of course. Of course. What are you seeing now more than anything?
You see, we have a couple that come in, there's still cylinders in use from 1972.
Of course, yeah. And you know, a lot of dive shops won't take them. One thing I like about Coral Reef is they'll like fill things that the shops in South Florida are like, no, we don't touch those. So when I have like trips down to South Florida, I'm really careful about what I bring down. They're so, you know, particular about older cylinders, especially. Hydrostatic testing. You know, I teach this in open water. What's the pressure? How much do we fill it to?
3,000.
How much in hydrostatic testing? Most are at 5/3 of the rated capacity. 5/3.
You said fill it to.
No, for hydrostatic testing. Sorry.
Yeah, if a cylinder is rated for 3,000, we pump it up to 5,000.
There you go.
For a steel at 3442, we would pump it up to what we would test at 3,500 through, and that would be at 5250. And in the process, especially with galvanized steels, we bring them up to 80% pressure because of the galvanization process. So that's going to make it change our reading a little bit. So we bring it to 80%, let it sit, check if there's leaks. We drain the system, re-level all of the readings, and then we repressurize it to 80%. We let it sit for 30 seconds to again check for leaks, and then we pump it up to 5250, measure the reading, and bring it down. After we've drained the pressure, we leave there's another chamber outside the cylinder that's just like static water pretty much. It goes into this rain measurement tube, and when the cylinder has all the pressure gone, it still has a permanent expansion. That's what we measured then.
Great. That's really helpful. So under pressure with water, in water, elastic expansion measurement. Must return to within the percent of the original. That's a destructive test.
Usually within 10%.
Yeah. And then the testing station stamping. Appropriate visual must also be done. And then here are some examples of what it might look like. Certified inspectors. So professional scuba inspectors. Advanced inspection technology, have appropriate equipment, certification liabilities. Are you certified to? No. Okay. Yeah, that's they need to get.
It's not that I know.
Yeah, no, you would know. Okay. Cylinder valves. Most of us know the valve functions, K, J, R, Y, DIN. You want to talk a little bit about that?
Built-in eye valve.
Right, let's talk about briefly.
Yeah, so the K valve is the most generic one you see. A J valve has two knobs on it. So you have the one for actually opening the cylinder, and the way these were designed was before pressure gauges existed.
And
So-
I've got one actually right there.
Yeah,
That's the old fashioned J valve one.
so they have this almost like a wire that comes down. And they would wait till they basically can't breathe anymore. Or some old regulators would make a bell sound almost, or some kind of noise. So then they'd pull down the wire, and that would allow them to breathe the rest of the cylinder, and it's like around the 500 range. So it's not a lot, but.
Yeah,
that was how they
back
did
in
it.
the day when they really did stupid stuff.
I'm not entirely sure what an R valve is. I don't know if I've seen that. Is that the tapered valve?
I think so. It's
Okay.
been a long, I'll see if maybe we have a slide. with a
The
picture.
Y valve is basically, it's a normal valve, but instead of one orifice on the face, there's two of them, and typically they have like these tiny butterfly looking things you turn to turn on like a normal handle. And it allows you to put two regulators on a single cylinder.
Why? Why?
Redundancy and regulator, but not the air supply.
That is-
Your Chinese twin, like stuff.
Oh, that's true. Then it would make sense, I guess.
I valves are commonly seen on O2 cylinders, but you can also see them on 2250 low pressure 72 steels. The ones on those are kind of weird looking. It's literally just what looks like a tube that just comes up, and it's got like the orifice, and then the little turning handle for it is on top. For O2 cylinders, it's actually, instead of like an actual thing you can turn, it either has like a little handle that's detachable on it, which is a little piece of metal, and it's like almost like a flat piece sticking up, and that's how you turn it on and off. The orifice is different between an O2 cylinder and like a regular scuba cylinder using the same type of valve. O2 cylinders have these two probes on them that go inside the valve. So if you don't have holes for the probes, it won't go on. Free breather divers, so find other ways.
What's the advantage of DIN over yoke?
So DIN is a encaptured O-ring. So as you know, with the yoke, whenever you're placing it on, you're supposed to put your hand over it in case the O-ring blows. Well, in DIN, you screw it in. So it's actually securing this O-ring in here. Even if the O-ring blows, it's not typically going to go flying anywhere. It's just going to be in there. Another reason why more tech divers like it is because yoke is just sitting on it, just using the pressure and the rear yoke part of it to hold it on. If they bumped into a structure a little too hard, it could jam it off or something, and it would come off and not be good. If it's DIN, like, you could hit it as hard as you want. At the most, it's gonna keep the regulator like stuck in it, so you can still breathe.
You shouldn't be hitting anything though. All right, let's move forward. So internal workings include safety burst discs. Has anyone seen a burst disc go before? I have. It's pretty intense. Have you seen one, Jacob? No?
No, yes.
I'm only, okay.
I've seen a lot.
Yeah.
We have a couple that have gone off just randomly in the service room.
Yeah, I think, didn't we saw one poolside before, Ronnie? No? You might not have been there. Okay.
Place.
Yeah, the reserve mechanism Jacob talked about on the J valve, we really don't use those cylinders anymore. And then the thread design and seal of the cylinder, Jacob talked on a little bit.
I can actually tell you what all these little parts are if you want.
No, we don't need to know that. Jacob, you have a great memory. I wish I had 1/10 of your brain functions capacity to recall information, but I don't. So, but yeah, obviously cleaning is needed, and look at the differences. So, scuba regulators, double hose versus single hose, single stage to two stage, first stage, intermediate pressure, and second stage. You want to talk on any of those?
So starting with like a first stage? what that does is that brings the pressure from the cylinder, which can be around 2250 up to 4500. Those are more SCBA cylinders, but scuba cylinders typically go to a max 3500. It takes that pressure and it brings it down around to a pressure of 120 psi to around 160 psi. It depends on the regulator and how that person wants it. Like state groups, they have us do it a certain way. Second stage, that takes the already lower pressure and brings it in, and it does slightly reduce it to about 1.2 to 1.4 psi. Very small, but it's like a lot whenever you press down the purge. We test this with a magnehelic measurement device, which is basically we take off the mouthpiece, we stick this other piece on, we slightly breathe through it, and we see when it starts to give to let the pressure come through. And that's the PSI that I'm going with, like with the 1.2. So it's not full PSI. If you hold down the purge button, it's just where it starts to break. Intermediate pressure, so 140 or so. Single stage, two stage, is that talking about like first, second stage, or is that like another system?
I think it's another system.
Okay. So I'm thinking that might have something to do with the Y valve.
Maybe so. All right, no worries. Okay. Let's move on. Aqualung first stage before cleaning and after cleaning with new parts. Theory of operation is next. Airflow and air travel. High pressure to intermediate. Valve seat, orifice, and disc. Upstream versus downstream. Balanced versus unbalanced. Piston versus diaphragm, and tilt valve. All right, let's see here. Tell us a little bit more about what we've taken.
So airflow and air travel is typically the resistance of the air traveling through to see how much is actually coming through. So this much needs to reach this point and be at this pressure, basically. High pressure to intermediate, so cylinder to the first stage, which takes it down to about 130 is the average, because once you start hitting 150, it starts to deteriorate the O-rings faster. Valve seat, orifice, and disc. Disc is the burst disc. Orifice is technically the same as the valve seat and an actual valve, because it's kind of all in one. So the orifice is the part that screws in, and the seat is actually attached on the bottom of it, and it's a high pressure seat. Upstream versus downstream, that's if you're on a regulator set, you attach it to the cylinder. Downstream is your second stages. Upstream using the hose is your first stage. So let's say as the O-ring disintegrates inside either one, this second stage isn't working, but this other second stage is working. So you know it's that second stage and not actually in the first stage. Because sometimes those pieces just explode inside and then it clogs it. Balanced versus unbalanced. So I prefer unbalanced, which is kind of weird.
Why?
I just prefer it.
Tell us why.
I
And
don't-
explain the difference.
I don't
again,
like-
why.
I don't like the way balanced feels.
Okay, so
Like it
tell
just
us the
breathes too
difference.
easy.
What's
So
the difference between balance and unbalanced?
balanced is taking pressure outside of the regulator and inside the regulator and trying to get it where everything stays the same throughout the depth. Unbalanced is not at all. So it stays how it is on the surface, and then the deeper you go, the less performance you get.
And why do you prefer unbalanced?
I
Especially since
don't
you like
like-
deep dives.
I don't like the way balanced regulators feel when I'm breathing them. They just feel way too easy to me, and it's just uncomfortable for me. I like a harder work of breathing, preferably. I don't know why I prefer it.
Yeah, I'm trying to figure that out.
I guess it's just lung size or something. Maybe I just like it.
Huh.
But balance just, it almost makes me sick. It's too much at once. I like being able to just barely get any air from it. I like to struggle.
He likes to struggle. He likes to
I
struggle,
understand that.
especially at depth.
Maybe it's like all the other pressure, you also want the pressure there. Just completely.
It's like a weighted blanket over your mouth.
Yeah.
I think you conserve air.
I think so, because I'm like one of the lowest air consumers.
Piston versus diaphragm. So piston is like what I have over there, which is Mark II Plus, and I believe you had a Sherwood Brute, right? Or is it a different one?
That's an aqua one.
Aqua, okay. It looked like a Brute. Basically, the piston is literally a piston. There's like this little piece in there. It's like a stick. It has this round piece on top with an O-ring. There's also an O-ring. There's no ring. There's a seat down here on this end, and it's completely open. It's kind of weird for it, but they chose to have it open in the middle, which there's not really a reason for that. It's just kind of open. The seat completely blocks off one end, and then on the other end you have a O-ring that goes around the outside of the piston. As you breathe, it pulls or either pushes the piston or something. It moves it, and if you're looking at it as you like purge it, sometimes you can see it move. You see it the easiest if you are pressurizing the system. So like on mine spring is blue, so if I pressurize it, I can actually see that spring move. Diaphragm. It's like this little rubber silicone thing,
Membrane.
membrane, and it just kind of bends and flexes. Piston's hard, it moves in and out. Tilt valve, no idea.
I was gonna ask you. All right.
I don't remember what that is.
Oh, that makes sense.
Okay,
Maybe the valve, the pre-dive valve.
maybe so.
I think that's it.
Let's call that just an adjustment.
Yeah.
I don't,
Oh, there's one more, sorry. Pilot valve.
well, now,
Somebody
seems like it
somebody
could be.
Google tilt valve and pilot valve. No, because my brain is not recalling this at all. No, my brain is not. Like,
Tilt means like it's limited. So that, I'm assuming that's what's on mine, and it's just like a little lever that changes the airflow in the system. I could be wrong, that's what I'm assuming it is.
the one where you just make an adjustment here.
No, so
Okay.
balanced second stage, have it where you can actually adjust the airflow. Unbalanced, it's literally just a switch, and it's just this little piece in there that just barely blocks the airway to change the turbulence inside. And I'm wondering if that's what those two are.
You have valves that tilt backward, don't they? I mean, they're obviously gonna tilt it all the way backwards.
Say that again, Bill?
Valves that have the stems that are kind of tilted back.
Okay, maybe so, maybe, I don't know. My brain is really not recalling it at all.
Yeah,
I'm like, this is like looking at something for the first time for me. It's.
I know on like the true 3500 steels, there are some valves that are not slightly angled, like you were saying.
Maybe that's it. Are you guys finding anything?
I think it's talking about the valve in the regulator. I
Okay.
think. I'm not
Yeah.
100% sure. I think it's saying there's different types of valves you can have within the regulator.
Yeah,
That'll change, I guess, how you breathe on it.
okay,
Sure.
all right, we'll,
Picture of it.
Oh,
so Jimena, where is it at? Is it internal to the regulator or is it external?
I haven't been able to.
That has nothing to do with regulation.
yes, it's that. Doesn't look good.
Okay, I'll tell you what.
Valve.
We'll just, we'll come back to that when I really don't think it's that important for your dive master. Let me just say that. Okay. First stage, cylinder to intermediate pressure, effective increasing depth, dry air bleed designs, oil or air seal designs, yoke and din fitting to cylinder, and then port sizes. You want to say anything about that, Jacob?
I don't like half inch.
That's the takeaway. He doesn't like half inch.
Yeah.
Why don't you like half inch ports?
So my very long hose is a half inch. Like it screws in as a half inch.
Yeah.
The problem is there's like hardly any regulators with a half inch opening on it.
Right.
So I have to create 2 more failure points
Mhm.
just to have an adapter on there so I could put it on. But cylinder intermediate pressure, effective increase in depth, that would be from like an unbalanced system would be like super noticeable. For some reason, I don't notice it, but
Which is why you love it.
yeah. Dry air bleed designs, that I think is like fizzy ports. I'm not sure. Some balanced systems, the first stage has this almost black, it looks like a black port plug, but it's almost like rubber. And what that's designed to do is fizz. So it's not like leaking drastically, it's just fizzing, and that balances everything. Normally that's on, I don't know if, I'm thinking Sherwood's. But,
I was thinking the same thing. Yeah.
That might be where that tilt valve is, because that's where it was on the other one and what it was saying and like the readings from the other ones.
All right. So second stages, intermediate to ambient pressure, downstream most common, diaphragm, pilot valve, venturi assist, adjustable spring, and backflow valves.
A little bit of something on the pilot valve.
Yeah, go ahead.
Add real quick. Pilot valves appear in the second stage only. So with the pilot valve, when you inhale, the diaphragm presses on a lever on a small valve releases air pressure, that in turn opens the larger main valve. Drawbacks to pilot valves, second stage include complexity and expense. They also tend to free flow easily. So most have dive/pre-dive switch. The pre-dive setting puts tension on the diaphragm so it doesn't free flow easily.
Okay.
Yeah.
All right. Excellent. Thank you, Ronnie.
Mhm.
And anything you want to say about this, Jacob?
Adjustable spring. See, it's not for a second stage, it's not a spring. There is only one spring typically in the second stage, and that is for the lever. But it's kind of adjustable, but you're not actually adjusting the spring. You're adjusting the orifice and how the seat is pressed against it. The seat is on top of this little white piece that holds it there. That's then on top of another piece of metal, and that's covered by like a spring, and that's how that moves. When you breathe in, there's a seal created inside the second stage, which causes the diaphragm to flex in, which pulls the lever, and that's what opens it.
Okay. What's venturi assist?
Heard of it?
Yes, I've heard of it too, and I don't have any recollection. Somebody Google venturi assist?
It's airflow.
Yeah.
Something to do with airflow.
Something to do with airflow. Okay. All right. Thank you. All right. LP hose, internal diameter, airflow to second stage, high pressure hose to 4,000 PSI.
5,000 now.
Okay, we should fix that then. Low pressure inflator hoses to BC, octopus, dry suit, and so on. Strain relief protectors and hose size and flexibility.
Don't buy flexos.
Dive site repairs, qualifications, recognizing problems, bring an extra regulator system. You guys know that I always bring extra everything. Have a save a dive kit too. That's something that's really helpful. How many of you have a save a dive kit? Just a little kit that has, yeah, just like some O-rings and straps and
Cars. Say.
It pretty much, my car is too, like there's an extra bin straps if somebody, mouthpiece, whatever. Free flows first stage versus second stage. I think we know what to do about second stage ones and, versus first stage.
First stage requires more tools and a little more effort.
Yeah. All right, so what if the gauge drops upon inhalation? That's another thing. When I set up my gear, I normally tell them to go ahead and breathe in and look at the gauge. If you see the needle moving, what does that tell you? If you see the needle moving when you're breathing in, like let's say you set up your gear and you're testing everything and you breathe in and the needle moves, what is that telling you?
On the PSI.
Uh-huh.
Mhm.
That's correct. Air is not all the way on. Almost always it's air is not all the way on. And so, and you know, I'll be like, well, you know, you sure you turned it? Oh yeah, it's all the way on. And I go over and then it's not all the way on. So, the gate, yeah, let's see, alternate air sources. An additional second stage integrated in the BC hose. Air 2 is what you have, isn't it, Jacob? Air source, shadow. I'm not a fan of those, as you know. Care of integrated octopus, seawater into inlet fitting. I'm not a fan of pony bottles or spare air either.
I hate spare.
I do
Pony
too.
bottles I can understand if it's up to 40 cubic foot, because then that's half you have, but spare air is literally nothing.
Yeah.
That's like a little.
It's kind of like back in the day, you know, even into the 80s, they would have a CO2 cartridge in people's cylinders so that if they ran out of air, they could just shoot themselves to the surface.
It was actually in BC, so
Yeah.
we had a couple of those come in.
Yeah,
It screws into the BC.
right.
And then you would almost like pull a cord or
Yeah.
maybe a lever or something. You hit that and it just instantly inflates your.
So you go,
BC.
yeah.
Just go flying. So instant eco sickness.
Amazing. Yeah. See, we've learned a lot. Information systems, analog gauges, Borden tubes, oil filled diaphragm capillary versus digital transducers, compasses, which can also be digital, and timing devices. I don't really think we need to get into the nitty gritty of those. Dive computers, square wave to dive profile concept, standalone versus air integrated. Accuracy and reliability, of course, is higher on on digital versus analog. Early mechanical to current electronic. Battery life and maintenance. Batteries are getting a lot better too. I know the older ones that I have an actual battery in them, and the newer ones now you plug in. There's pluses and minuses to both of those.
There's some now, phones are wireless charging, some of them are. They do have some dive computers that can wirelessly charge. And also found
Yeah.
out while I was doing my deco, e-learning and everything. In most computers, you can set a gradient factor, which is how conservative you are, and how saturated
Yeah.
your tissues get.
Yeah, definitely. I mean, even on ours, you could definitely change the settings for when it alerts you and your PO2 level and all kinds of different things you can get into. So general care after a dive, we all know what to do, right? Press the buttons and the water and such. Hose disconnect fittings. Buoyancy compensators, transitions from the 1950s included front mount, back mount, wraparound, side mount, inflation systems, oral power inflator, integrated octopus. BC. Go ahead.
Milk jugs.
Yeah, okay. All right. BC care and maintenance, bladder versus bladderless, inflation fittings and valves, cleaning the bladder, attachment for hoses, integrated weights, droppable versus non-drop. What do you want to say about cleaning the bladder, Jacob?
So there's a couple different ways of doing it. We use what's called, I think, sludge, or either another one. Basically, if you're servicing it, which is kind of when you would also do this if you wanted to, we typically don't clean anything, except for the display masks. But the BC, you take all the dumps off, but except for the bottom one, if you wanted to have it hold the liquid and slosh it around or whatever. Clean in the dump valves, and depending on what you're using, you can let it sit for a little bit just to let it kind of aerate in there or something. And then rinse it all out. If you have all the dump valves completely unscrewed off, then you can typically just take some kind of water supply and just run it through it. And then when you're done, it's best to dry it fairly quickly with like some kind of like pressurized air. So you can take, we have a bench that's actually set up so we can just grab it, shoot air and something and dry it off really quickly. You just shoot this pressurized air in it and dry it all, because it needs to be dry, especially with regulators, because it can corrode and stuff, or the springs can rust, and salt crystals if it's got salt in it, and etc. Most salt crystals accumulate on the lower dump valve. Sand, however, accumulates on the shoulder valves.
Which you just learned tonight, right? You got affirmation of that tonight. All right. So we're gonna end here. And you know, we just talked a little bit about equipment mechanics, becoming qualified to repair, making dive site repairs, legal risk assumption. We didn't actually talk about that. I don't know why it's in the summary. The importance of proper maintenance and keep records of all gear. So next time we'll start with decompression theory, but I think it's too late to even begin to consider that right now. So I'm gonna, I mean, you know, I said we would end at 9, so we're gonna end. So we're definitely not gonna get into decompression theory right now. So I'm going to stop the share and I'm going to end the meeting. And at least